The mosquito known as Aedes aegypti originated in Africa. Over the last 400 years, it has spread throughout all tropical regions of the world, transmitting viruses to people. We are working on a way to stop this mosquito from transmitting dengue. Our method uses naturally occurring bacteria called Wolbachia that live inside insect cells and are passed from one generation to the next through the insect's eggs. Wolbachia are found naturally in up to 60% of all the different species of insects. Insects that include fruit flies, moths, dragonflies, and butterflies. The secret to the success of Wolbachia is how it manipulates the reproduction of the insects it lives in, so to give itself an advantage. It works like this. If a male insect has Wolbachia and mates with a female that doesn't, then the eggs she lays won't hatch. If the female has Wolbachia and the male doesn't, she would lay her normal number of eggs. They would all hatch, and all offspring will carry Wolbachia. When two insects that both carry Wolbachia mate, the eggs will hatch, and all offspring will carry Wolbachia. Over a few generations, the number of individuals carrying Wolbachia increases rapidly until nearly all the insects within a population have the bacteria. We wanted to see if we could use Wolbachia as a way to stop dengue transmission. To do this, we first had to move Wolbachia into the mosquito so that it would grow and be passed between generations. Using microscopic needles, we took Wolbachia from the fruit fly and injected it directly into young Aedes aegypti eggs. It took us thousands and thousands of attempts, but finally, we were successful. We then took the mosquitoes that contained Wolbachia and infected them with dengue, and found something really exciting. The virus didn't grow well in the mosquito, and if it can't grow, it can't be passed between people. Our next step was to build large enclosed outdoor cages in northern Australia that we filled with local mosquitoes. We then introduced mosquitoes containing Wolbachia to see if it could spread into the cage population, and it did. We now wanted to test the method where dengue is found, but before we did this, we needed the government to examine the safety of our method and approve our trials. Then we needed to gain the support and approval of communities to release mosquitoes containing Wolbachia. With these approvals, we began our first open field trials in Australia in 2011. Wolbachia mosquitoes were released once a week for 10 weeks, and within a few months, close to 100% of the mosquitoes had Wolbachia. And years later, they still do. Ongoing trials in Australia and dengue endemic countries are now determining the best way to deploy Wolbachia across whole cities. It is our hope that with continued success, the Wolbachia control method will protect the health of the 2.5 billion people that live in dengue transmission areas.